Have you ever looked up at the night sky and wondered about the vastness of the universe? Ever wondered what lies beyond our blue planet? Well, welcome, fellow explorers. Get ready for an incredible journey as well as welcome to a cosmic expedition and adventure. Today, we embark on a journey through the fascinating solar system, a collection of celestial bodies orbiting around our sun.
Our story begins not on Earth but in the vast expanse of space billions of years ago. Imagine a dark, cold cloud of gas and dust, a stellar nursery known as a nebula. These nebulae are scattered throughout the universe, remnants of long-gone stars. Within these clouds, gravity, the architect of the cosmos, slowly draws particles together. Over eons, this gravitational pull intensifies as more and more material clumps together. The cloud, no longer static, begins to spin, slowly at first, then faster and faster like a pirouetting dancer. As the cloud collapses in on itself, the center heats up, glowing with a nascent energy. This is the beginning of our solar system, a cosmic ballet set in motion by the fundamental forces of the universe. From this maelstrom of gas and dust, a star, our sun, will be born. And around it, a swirling disk of debris will coalesce, eventually forming the planets, moons, and asteroids that make up our solar neighborhood. The collapsing cloud, now a spinning disk of gas and dust, is known as a solar nebula. At the center, the protostar, a baby star in the making, gathers mass and heat. Around it, the remaining material continues to whirl, a chaotic dance of particles constantly colliding. These collisions, though seemingly random, are the key to planet formation. Tiny grains of dust, remnants of ancient stars, collide and stick together like cosmic Velcro. These minuscule clumps, no larger than grains of sand, are the seeds of planets, the building blocks of our solar system. As the nebula spins, it flattens out like a spinning top. The lighter elements, hydrogen and helium, are pushed to the outer regions, while heavier elements like iron and silicon remain closer to the protostar. This distribution of elements will have a profound impact on the types of planets that form. As the protostar at the center of the solar nebula continues to pull in gas and dust, its core grows hotter and denser. Temperatures and pressures soar, reaching a critical threshold. At this point, a process known as nuclear fusion ignites, flooding the surrounding space with light and heat. Hydrogen atoms, the simplest and most abundant element in the universe, fuse together to form helium, releasing tremendous energy in the process. This energy, radiating outward, pushes against the inward pull of gravity, creating a delicate balance. The protostar, now a true star, our sun, is born. The sun's ignition marks a turning point in the evolution of our solar system. Its powerful gravity now governs the motions of all the objects within its reach. The solar wind, a stream of charged particles emanating from the sun, sweeps through the solar system, shaping the remaining material and influencing the formation of planets. In the swirling chaos of the solar nebula, dust grains forged in the hearts of long-dead stars continue to collide and stick together, growing larger over time. These larger clumps, now called planetesimals, have a stronger gravitational pull, attracting more and more material. As planetesimals grow, their orbits around the sun become more defined. Some collide and merge in spectacular events, creating even larger bodies. Others are flung out of the solar system entirely, lost in the vastness of space. Over millions of years, this process of accretion, collision, and gravitational interaction shapes the solar system into the familiar arrangement we see today. Rocky planets like Earth and Mars form closer to the sun, while gas giants like Jupiter and Saturn coalesce in the colder outer reaches. Section 5. Diverse worlds, rocky neighbors and gaseous giants. The planets that emerge from the solar nebula are as diverse as the elements from which they are formed. The inner solar system, bathed in the sun's heat, is home to the rocky planets, Mercury, Venus, Earth, and Mars. These planets, formed from heavier elements that could condense in the intense heat, are relatively small and dense. Further out, beyond the frost line, where temperatures are much colder, gas giants reign supreme. Jupiter, Saturn, Uranus, and Neptune, formed from lighter elements like hydrogen and helium, are behemoths, dwarfing the inner planets. These gas giants, with their swirling atmospheres and complex ring systems, are worlds unto themselves. The asteroid belt, a band of rocky debris located between Mars and Jupiter, is a relic of the solar system's formation. These asteroids, remnants of planetesimals that never coalesced into planets, provide a glimpse into the early solar system, a time of chaos and creation. Section 6. Earth's tumultuous youth, a planet forged in fire. Earth, our home planet, formed in the inner solar system, a region of intense heat and bombardment. The early Earth was a molten ball of rock, constantly pummeled by asteroids and comets. These impacts, while destructive, also delivered water and other volatile compounds, essential ingredients for life. Volcanoes erupted across the planet's surface, spewing lava and gases into the atmosphere. These gases, including water vapor, carbon dioxide, and nitrogen, created Earth's primordial atmosphere, a toxic mix hostile to life as we know it. As Earth cooled, the water vapor in the atmosphere condensed, forming vast oceans. These oceans, along with the planet's internal heat and the energy from the sun, would provide the crucible for life to emerge. Section 7. Life finds a foothold, a pale blue dot, teeming with wonder. In the warm, shallow seas of the early Earth, a remarkable event occurred. From the primordial soup of organic molecules, life emerged, simple, single-celled organisms capable of replicating themselves. This event, the origin of life, is one of the greatest mysteries in science. Over billions of years, life on Earth evolved and diversified, from single-celled organisms to complex plants and animals. Photosynthesis evolved, releasing oxygen into the atmosphere and paving the way for the evolution of oxygen-breathing organisms. The history of life on Earth is a testament to the power of evolution, the ability of life to adapt and thrive in the face of changing environments. From the depths of the oceans to the heights of the atmosphere, life has flourished on our planet, transforming it into the vibrant, teeming biosphere we see today. Section 8. Outer giants, rings of splendor, and storms of fury. The outer solar system is a realm of gas giants, each with its own unique features. Jupiter, the largest planet in our solar system, is a swirling mass of colorful clouds punctuated by the Great Red Spot, a storm that has raged for centuries. Saturn, the ringed planet, is a celestial wonder. Its intricate rings a testament to the beauty and complexity of the cosmos. Uranus, the ice giant, is tilted on its side, its rings and moons orbiting in a plane almost perpendicular to the plane of the solar system. Neptune, the farthest planet from the Sun, is a world of supersonic winds and powerful storms, its deep blue atmosphere a testament to its distant, frigid location. The outer planets, with their swirling atmospheres, intricate ring systems, and diverse collections of moons, are a reminder of the vastness and diversity of the cosmos. They are worlds unto themselves, each with its own story to tell, each a testament to the power of gravity and the beauty of the universe. Section 9. Our place in the cosmic tapestry, awe, wonder, and the search for meaning. Our journey through the formation and evolution of our solar system has taken us from the birth of a star to the emergence of life on our planet. We have witnessed the power of gravity, the beauty of the cosmos, and the resilience of life. As we gaze out at the night sky, we are filled with awe and wonder. We are reminded of our place in the universe, a tiny planet orbiting an average star in a vast and ancient cosmos. Yet we are also reminded of our own significance, the only known harbor for life in the universe. The search for meaning is a fundamental human endeavor. As we continue to explore the cosmos, we are driven by a desire to understand our place in the universe and to search for other life beyond Earth. The story of our solar system is a story of creation, evolution, and the interconnectedness of all things. It is a story that continues to unfold, a story that inspires us to explore, to discover, and to imagine.
Hello, fellow space enthusiasts. Today we embark on a celestial journey as we explore the wonders of our solar system. Get ready to be awestruck by the beauty and complexity that lies beyond our Earth's atmosphere. Buckle up for an unforgettable adventure. Let's start our journey at the heart of our solar system, the mighty Sun. Our brilliant star, composed mostly of hydrogen and helium, provides us with warmth, energy, and light. It's the gravitational force of the sun that holds our solar system together. As we travel away from the sun, we encounter an awe-inspiring collection of celestial bodies. The first planet we come across is Mercury, the closest to the sun. But don't be fooled by its small size. It's a scorching hot planet, inhospitable for life as we know it. Moving further out, we encounter Venus, the hottest planet in our solar system. Its thick atmosphere traps heat, creating a runaway greenhouse effect. It's like a planetary pressure cooker. And now, we reach the planet we call home, Earth. Our blue planet is teeming with life, thanks to a unique combination of elements, moderate temperatures, and the presence of water. It truly is a remarkable oasis in the vastness of space. As we venture further, we approach the enigmatic red planet, Mars. With its dusty, barren surface, Mars has long captivated human imagination and fueled dreams of future exploration. Moving even farther from the Sun, we encounter the largest planet in our solar system, Jupiter. It's a mesmerizing giant, composed primarily of hydrogen and helium. But it's not just its size that's extraordinary. Our journey would be incomplete without a visit to the captivating ringed planet, Saturn. Its iconic rings are composed of countless particles ranging in size from tiny grains to massive chunks of ice. As our celestial journey comes to an end, we are reminded of the grandeur and complexity of our solar system. From the scorching heat of Mercury to the icy splendor of Saturn's rings, every planet has its own unique story to tell. It's up to us to continue exploring, learning, and protecting the beauty of our solar system. Let us celebrate the marvels of the cosmos and strive to unravel more of its mysteries. Until next time, keep looking up.
Welcome, ladies and gentlemen, to this captivating journey through our magnificent solar system. Today we embark on a voyage filled with wonder and awe as we explore the fiery heart of our existence, the Sun. As we venture closer to the Sun, we unveil its captivating secrets, uncovering in the process some of the many intriguing and fascinating facts about this celestial body that has held humanity's fascination for millennia. And did you know that the Sun, our brilliant star, is approximately 4.6 billion years old? In comparison, the Earth is just a young 4.5 billion years old. It's astonishing to think that this giant ball of gas has been providing us with life-sustaining energy for such an unfathomable amount of time. As we explore its unfathomable dimensions, we come to realize that the Sun is absolutely massive. In fact, it is so enormous that it holds 99.86% of the total mass of our entire solar system. Imagine that. It's like a cosmic giant, effortlessly holding together all the other celestial bodies within its gravitational embrace. Now let's take a closer look at the Sun's fascinating energy-producing processes. The Sun generates its immense power through a natural nuclear fusion process known as thermonuclear reactions. In the core, hydrogen atoms fuse together, creating helium and releasing an enormous amount of energy in the process. This energy then radiates out into space, illuminating our solar system. The Sun's core temperature is an astounding 15 million degrees Celsius. To put that into perspective, it's almost 27 million degrees Fahrenheit. This immense heat and pressure enable nuclear fusion to occur, releasing an estimated 383 billion trillion watts of energy every second. It's mind-boggling to comprehend the sheer magnitude of this energy production. While we are all aware of the Sun's radiant brightness, its surface is actually not smooth. The distinct pattern we see is due to the presence of sunspots, cooler areas compared to the surrounding plasma. Sunspots are temporary phenomena caused by intense magnetic fields, resulting in reduced surface temperature. They often appear as dark spots or patches, adding a unique visual element to an already breathtaking spectacle. As we marvel at the sun's beauty, it is crucial to remember that it is not without its dangers. The sun's immense energy can also produce solar flares and coronal mass ejections, or CMEs, violent eruptions that expel charged particles into space. These can interfere with our technological infrastructure and even pose risks to astronauts in space. Understanding the sun's activity is vital for our scientific advancements and ensuring the safety of space exploration. Today, we've only scratched the surface of the sun's mesmerizing attributes, from its immense size and staggering energy production to the captivating patterns of sunspots and the potential dangers of solar flares. The sun continues to captivate, inspire, and shape our understanding of the universe. Join me on this ongoing journey of cosmic exploration, where we delve into the mysteries of our universe and uncover the awe-inspiring wonders that await us. Together we can continue to celebrate the magnificence that is the sun. Our solar system is a vast and awe-inspiring place. At its heart lies the sun, a giant ball of burning gas that provides light and warmth to its orbiting family of planets. The sun's powerful gravity holds everything together, from the smallest asteroid to the largest gas giant. Around the sun, 8 planets dance in a delicate gravitational ballet. These planets, each with its own unique characteristics, make up our solar system. They range in size from small rocky worlds to massive gas giants. The distances between these planets are vast, measured in millions of kilometers. Despite their differences, all the planets in our solar system share a common origin. They were formed billions of years ago from a swirling cloud of gas and dust. As we explore each planet in turn, we will uncover their secrets and marvel at the wonders of our solar system. Join us on this journey of discovery as we delve into the unknown. Closest to the sun, Mercury races around our star at an incredible speed. This small, rocky planet is a world of extremes. During the day, its surface bakes in the sun's intense heat. Temperatures can soar to over 400 degrees Celsius or 750 degrees Fahrenheit. But at night, with no atmosphere to trap the heat, Mercury plunges into a deep freeze. Temperatures plummet to minus 180 degrees Celsius or minus 290 degrees Fahrenheit. This makes Mercury's temperature swing the most extreme in the solar system. Mercury's surface is heavily cratered, bearing the scars of countless asteroid impacts. It is also home to cliffs and plains, evidence of its ancient geological activity. One of the most striking features on Mercury is the Caloris Basin, a giant impact crater over 1,500 kilometers or 950 miles wide. Despite its harsh conditions, Mercury is a fascinating world that continues to intrigue scientists. NASA's Messenger spacecraft spent 4 years orbiting Mercury, providing invaluable data and stunning images of this enigmatic planet. Second from the Sun, Venus is often called Earth's twin. Venus is shrouded in a thick toxic atmosphere composed mainly of carbon dioxide. This dense atmosphere traps heat, creating a runaway greenhouse effect. Temperatures on Venus soar to over 460 degrees Celsius, making it the hottest planet in our solar system. The pressure at the surface is 90 times that of Earth's. Venus's clouds are made up of sulfuric acid, which evaporates before reaching the ground. Despite its hostile environment, Venus has been the target of numerous missions. Spacecraft have revealed a landscape shaped by volcanoes and vast plains. Third from the Sun, Earth is a unique and precious planet. It is the only known world in our solar system that harbors life. This is due in part to its ideal distance from the Sun, which allows for liquid water to exist on its surface. Earth's atmosphere is another key factor in its habitability. It provides the air we breathe, protects us from harmful radiation, and regulates the planet's temperature. The atmosphere is a delicate balance of nitrogen, oxygen, and other gases. Our planet is a dynamic world with constantly shifting continents, vast oceans, and a diverse array of ecosystems. From the icy poles to the lush rainforests, Earth teems with life. Our planet is a testament to the wonders of the universe and the delicate balance of conditions that make life possible. As we explore other planets and celestial bodies, we gain a deeper appreciation for the fragility and preciousness of our own planet. Earth is our home, and it is up to us to protect and cherish it for future generations. Fourth from the Sun, Mars has captivated humans for centuries. Its reddish hue, visible even to the naked eye, earned it the nickname the Red Planet. This coloration comes from iron oxide or rust present in its soil. Mars is a cold, dry planet with a thin atmosphere. It is home to the largest volcanoes in our solar system, including Olympus Mons, which is 3 times taller than Mount Everest. Mars also boasts Valles Marineris, a canyon system so grand it makes the Grand Canyon look like a small ditch. Evidence suggests that Mars was once a much warmer and wetter planet than it is today. Dried-up riverbeds, ancient lake basins, and polar ice caps hint at a watery past. This has led scientists to believe that Mars may have once harbored life, and the search for evidence of past or present microbial life continues to be a driving force in Mars exploration. Today, robotic rovers roam the Martian surface, sending back valuable data and stunning images. The dream of sending humans to Mars is becoming increasingly tangible as we continue to unlock the secrets of this enigmatic world. Fifth from the Sun, Jupiter is a true giant. It is the largest planet in our solar system, with a mass greater than all the other planets combined. Jupiter is a gas giant, composed primarily of hydrogen and helium. Its swirling clouds are a mesmerizing tapestry of colors and patterns. The Great Red Spot is a giant storm that has been raging for centuries. Jupiter has at least 79 moons, with Io, Europa, Ganymede, and Callisto being particularly intriguing. Io is the most volcanically active body in our solar system. Europa may harbor a vast ocean of liquid water beneath its icy surface. Ganymede is the largest moon in our solar system. Callisto is the most heavily cratered object in our solar system. Jupiter and its moons offer endless opportunities for exploration and discovery. Sixth from the Sun, Saturn is a breathtaking sight to behold. Its iconic rings, visible even with a small telescope, make it one of the most recognizable objects in our solar system. These rings are made up of countless particles of ice and rock, ranging in size from tiny grains to large boulders. Saturn is a gas giant, like Jupiter, composed mostly of hydrogen and helium. It is the second largest planet in our solar system, but it is also the least dense. In fact, Saturn is less dense than water, meaning it could theoretically float in a bathtub if you could find one big enough. Saturn's rings are not solid, but are actually made up of billions of individual particles, each orbiting the planet like tiny moons. The rings are incredibly thin, only a few hundred meters thick in most places. Like Jupiter, Saturn has a large number of moons, with at least 82 confirmed so far. One of its most intriguing moons is Titan, the second largest moon in our solar system. Titan is unique in that it has a dense atmosphere, mainly composed of nitrogen, similar to Earth's early atmosphere. Seventh from the Sun, Uranus is a true oddball. This ice giant is tilted on its side, with its axis of rotation nearly parallel to its orbital plane. This means that Uranus essentially spins on its side as it orbits the Sun. The cause of Uranus's unusual tilt is unknown, but it is thought to have been the result of a collision with a large object early in its history. This collision may have also been responsible for the formation of Uranus's rings and moons. Uranus has a faint ring system discovered in 1977 and at least 27 known moons. Its atmosphere is composed primarily of hydrogen and helium, but it also contains methane, which gives Uranus its distinctive blue-green color. Uranus is a cold and distant world, with temperatures in its upper atmosphere plummeting to -224 degrees Celsius or -371 degrees Fahrenheit. Despite its distance and unusual orientation, Uranus is a fascinating world that continues to intrigue scientists. Eighth and farthest from the Sun, Neptune is a dark and stormy world. This ice giant is similar to Uranus, with an atmosphere of hydrogen, helium, and methane. Neptune's blue color is more intense than Uranus's. Neptune is very windy, with speeds over 2,100 kilometers per hour. These are the fastest winds in our solar system. Neptune's Great Dark Spot is a giant storm, similar to Jupiter's Great Red Spot. Neptune has 14 known moons, the largest being Triton. Triton orbits Neptune in the opposite direction, suggesting it was captured by Neptune's gravity. Neptune is a cold world with a surface temperature of minus 214 degrees Celsius. Despite its distance, Neptune continues to reveal its secrets to us. As we venture beyond the 8 known planets, we enter a realm of icy bodies and dwarf planets. Pluto, once considered the 9th planet, now resides in this region known as the Kuiper Belt. This vast and distant region is home to countless icy objects, remnants from the early solar system. Beyond the Kuiper Belt lies the Oort cloud, a theoretical sphere of icy bodies that is thought to extend trillions of kilometers from the Sun. This region is believed to be the source of long-period comets which occasionally grace our skies with their icy tails. The exploration of our solar system is an ongoing journey. New discoveries are constantly being made, challenging our understanding of the universe and our place within it. From the fiery heart of the Sun to the icy depths of the Oort cloud, our solar system is a place of wonder and endless possibilities. Our journey through the solar system has taken us to scorching hot worlds and frigid icy plains. We have encountered giant storms, towering volcanoes, and vast rings of ice and dust. We have glimpsed the possibility of life beyond Earth and stood in awe of the sheer scale and grandeur of the cosmos. As we continue to explore our solar system and beyond, we are filled with a sense of wonder and excitement. The universe is a vast and mysterious place, and we're only just beginning to scratch the surface of its secrets. Each new discovery brings us closer to understanding our place in the cosmos. It reminds us of the power of human curiosity and our innate desire to explore the unknown.
Our solar system is full of wonders. From the blazing sun at its center to the icy edges of the Kuiper Belt, it is a vast and diverse place. Each planet, moon and asteroid has its own story to tell, its own mysteries to uncover. We know about planets like Mars, with its dusty red surface and towering volcanoes, Jupiter, with its swirling storms and the iconic Great Red Spot, and Saturn, with its stunning rings that have fascinated astronomers for centuries. But did you know there are hidden planets too? These are worlds that lie beyond our current reach, shrouded in mystery and waiting to be discovered. They are not easily seen with our current technology, but they exist lurking in the shadows of our solar system. These planets are far away and hard to see. They're often obscured by the glare of their parent stars or hidden in the vastness of space. Yet with each passing year, our technology improves, bringing these distant worlds into clearer focus. But they are out there waiting to be explored. Imagine the thrill of discovering a new planet, a world that no one has ever seen before. Spacecraft and telescopes are our eyes in the cosmos, helping us to uncover these hidden gems. Imagine a planet with giant rings, even bigger than Saturn's. These rings could be made of ice, rock, or even dust, creating a spectacular display that would be visible from millions of miles away. Picture a world covered entirely in ice, reflecting the sunlight like a mirror. This planet could have vast frozen oceans, towering ice cliffs, and perhaps even life forms adapted to the extreme cold. These hidden planets hold secrets and surprises. They could have unique atmospheres, strange weather patterns, or even exotic forms of life. Each one is a new frontier, a new opportunity for discovery. Scientists are always searching for new planets. They analyze data from telescopes, study the movements of stars, and look for the faint signals that indicate the presence of a new world. They use powerful telescopes to look deep into space. These instruments can detect the faintest glimmers of light from distant planets, helping us to map the far reaches of our solar system and beyond. Who knows what amazing discoveries await us? With each new planet we find, we learn more about our place in the universe. The search for hidden worlds is a journey of exploration and wonder, and it is only just beginning. Let's embark on an extraordinary journey to a hidden planet called X2R7. This isn't just any planet. It's a world full of wonders waiting to be discovered. As we travel through the vast expanse of space, imagine the excitement of approaching a planet that holds secrets unlike any other. X2R7 is a gas giant, much like our own Jupiter, with its massive swirling clouds and immense size. However, there's something truly unique about this distant world that sets it apart from the gas giants we are familiar with in our solar system. But X2R7 is very different in one amazing way. Its atmosphere is filled with vibrant colors and patterns that are unlike anything we've ever seen before. The planet's unique chemical composition creates a mesmerizing display that captivates anyone who gazes upon it. It has auroras that light up the sky with neon colors. These auroras are not just ordinary light shows, they are spectacular displays of neon hues that dance across the sky, creating a visual feast for the eyes. Auroras happen when particles from the sun interact with the planet's atmosphere. This interaction causes the particles to become energized, resulting in the beautiful light displays we see. On X2R7, this process is amplified, leading to even more stunning auroras. On Earth, we see green and pink auroras, which are already breathtaking. These colors are produced by the interaction of solar particles with the gases in our atmosphere, primarily oxygen and nitrogen. But on X2R7, the auroras are bright blue, electric purple, and even fiery orange. These colors are the result of different gases and elements in the planet's atmosphere, creating a palette of colors that is truly out of this world. Imagine standing on a moon orbiting X2R7. From this vantage point, you would have a front row seat to the most incredible light show in the universe. The sky above would be filled with swirling colors and patterns, a constant reminder of the beauty and mystery of the cosmos. The sky above would be a dazzling light show. Every night you would witness a new and unique display of colors, each one more beautiful than the last. The auroras would dance and shimmer, creating a sense of wonder and awe. It would be a breathtaking spectacle of color and light. The experience of witnessing such a phenomenon would be unforgettable, leaving you with a deep appreciation for the wonders of the universe. X2. R7 is truly a neon spectacle, a testament to the beauty and diversity of the cosmos. Next, we travel to planet Z5T2, a rocky planet like Earth. But Z5T2 has a very unusual feature. Its gravity is much weaker than ours. Because of the weak gravity, things on Z5T2 float easily. Imagine jumping high in the air and landing softly like a feather. You could even lift giant rocks with your bare hands. Z5T2 is also home to floating islands. These islands are made of rock and ice. They drift slowly across the sky, casting long shadows on the ground below. Our final destination is planet Q9J4, a world that has intrigued scientists and explorers alike for decades. This planet is a mystery wrapped in clouds, a celestial enigma that has kept its secrets well hidden. Q9J4 is completely covered in thick, swirling clouds, making it impossible to see what lies beneath from our vantage point in space. We can't see its surface from space, and this has only fueled our curiosity and imagination. Scientists believe that Q9J4 might have a warm, watery surface, potentially teeming with unknown forms of life. Some even think there could be life hidden beneath the clouds, life forms that have adapted to the unique conditions of this mysterious world. Imagine a planet with floating cities hidden from view. These cities could be home to advanced civilizations, living in harmony with the planet's environment. Exploring Q9J4 would be a challenge, requiring advanced technology and brave explorers willing to venture into the unknown. But it would also be an incredible adventure, a journey that could change our understanding of the universe and our place in it. What secrets lie beneath the clouds? Could there be ancient ruins, hidden treasures, or new forms of life waiting to be discovered? We can only imagine until we dare to explore. The mysteries of Q9J4 beckon us, inviting us to uncover its secrets and expand our horizons. These hidden planets are just a glimpse of the wonders that might exist. Space is vast and mysterious. There are countless celestial bodies waiting to be discovered. Each one holds the potential for breathtaking discoveries. The thought of finding new planets, with new landscapes and new possibilities, is incredibly exciting. It sparks our curiosity and fuels our desire to explore the universe around us. One of the most profound questions we ask is, are we alone? The search for extraterrestrial life is a driving force behind space exploration. Finding even the smallest sign of life elsewhere would be a monumental discovery. Imagine the impact of discovering alien life. It would change our understanding of the universe and our place in it. It's a tantalizing possibility that keeps us reaching for the stars. Section 7. Advancements in space exploration. We are living in a golden age of space exploration. New technologies are constantly being developed, allowing us to explore farther and learn more than ever before. From powerful telescopes that can see billions of light years away to robotic probes exploring the surfaces of distant planets, we are making incredible strides in uncovering the secrets of the cosmos. Section 8. Inspiring future generations. Space exploration is not just about scientific discovery, it's also about inspiration. When we look up at the stars, we are reminded of the boundless possibilities that exist. Sharing the wonders of space with young people ignites their imaginations. It encourages them to pursue careers in science, technology, engineering, and mathematics, ensuring that the spirit of exploration continues for generations to come. Section 9. The importance of continued research. Continued research and exploration are crucial to unraveling the mysteries of the universe. Every new discovery brings us closer to understanding our place in the cosmos. By investing in space exploration, we invest in the future of humanity. We push the boundaries of knowledge, develop new technologies, and inspire generations to come. Section 10. Our place in the cosmos. As we explore the vast expanse of space, we gain a deeper appreciation for the fragility and interconnectedness of life on Earth. We are part of something much larger than ourselves, a cosmic tapestry woven with stars, planets, and the infinite possibilities of the universe. Let us continue to explore, to learn, and to marvel at the wonders that await us in the great unknown. Our solar system is full of wonders. From the blazing sun at its center to the icy edges of the Kuiper Belt, it is a vast and diverse place. Each planet, moon, and asteroid has its own story to tell, its own mysteries to uncover. We know about planets like Mars, with its dusty red surface and towering volcanoes, Jupiter, with its swirling storms and the iconic Great Red Spot, and Saturn, with its stunning rings that have fascinated astronomers for centuries. But did you know there are hidden planets too? These are worlds that lie beyond our current reach, shrouded in mystery and waiting to be discovered. They are not easily seen with our current technology, but they exist lurking in the shadows of our solar system. These planets are far away and hard to see. They're often obscured by the glare of their parent stars or hidden in the vastness of space. Yet with each passing year, our technology improves, bringing these distant worlds into clearer focus. But they are out there waiting to be explored. Imagine the thrill of discovering a new planet, a world that no one has ever seen before. Spacecraft and telescopes are our eyes in the cosmos, helping us to uncover these hidden gems. Imagine a planet with giant rings, even bigger than Saturn's. These rings could be made of ice, rock, or even dust, creating a spectacular display that would be visible from millions of miles away. Picture a world covered entirely in ice, reflecting the sunlight like a mirror. This planet could have vast frozen oceans, towering ice cliffs, and perhaps even life forms adapted to the extreme cold. These hidden planets hold secrets and surprises. They could have unique atmospheres, strange weather patterns, or even exotic forms of life. Each one is a new frontier, a new opportunity for discovery. Scientists are always searching for new planets. They analyze data from telescopes, study the movements of stars, and look for the faint signals that indicate the presence of a new world. They use powerful telescopes to look deep into space. These instruments can detect the faintest glimmers of light from distant planets, helping us to map the far reaches of our solar system and beyond. Who knows what amazing discoveries await us? With each new planet we find, we learn more about our place in the universe. The search for hidden worlds is a journey of exploration and wonder, and it is only just beginning. Let's embark on an extraordinary journey to a hidden planet called X2R7. This isn't just any planet. It's a world full of wonders waiting to be discovered. As we travel through the vast expanse of space, imagine the excitement of approaching a planet that holds secrets unlike any other. X2R7 is a gas giant, much like our own Jupiter, with its massive swirling clouds and immense size. However, there's something truly unique about this distant world that sets it apart from the gas giants we are familiar with in our solar system. But X2R7 is very different in one amazing way. Its atmosphere is filled with vibrant colors and patterns that are unlike anything we've ever seen before. The planet's unique chemical composition creates a mesmerizing display that captivates anyone who gazes upon it. It has auroras that light up the sky with neon colors. These auroras are not just ordinary light shows, they are spectacular displays of neon hues that dance across the sky, creating a visual feast for the eyes. Auroras happen when particles from the sun interact with a planet's atmosphere. This interaction causes the particles to become energized, resulting in the beautiful light displays we see. On X2R7, this process is amplified, leading to even more stunning auroras. On Earth, we see green and pink auroras which are already breathtaking. These colors are produced by the interaction of solar particles with the gases in our atmosphere, primarily oxygen and nitrogen. But on X2R7, the auroras are bright blue, electric purple, and even fiery orange. These colors are the result of different gases and elements in the planet's atmosphere, creating a palette of colors that is truly out of this world. Imagine standing on a moon orbiting X2R7. From this vantage point, you would have a front row seat to the most incredible light show in the universe. The sky above would be filled with swirling colors and patterns, a constant reminder of the beauty and mystery of the cosmos. The sky above would be a dazzling light show. Every night you would witness a new and unique display of colors, each one more beautiful than the last. The auroras would dance and shimmer, creating a sense of wonder and awe. It would be a breathtaking spectacle of color and light. The experience of witnessing such a phenomenon would be unforgettable, leaving you with a deep appreciation for the wonders of the universe. X2. R7 is truly a neon spectacle, a testament to the beauty and diversity of the cosmos. Next, we travel to planet Z5T2, a rocky planet like Earth. But Z5T2 has a very unusual feature. Its gravity is much weaker than ours. Because of the weak gravity, things on Z5T2 float easily. Imagine jumping high in the air and landing softly like a feather. You could even lift giant rocks with your bare hands. Z5T2 is also home to floating islands. These islands are made of rock and ice. They drift slowly across the sky, casting long shadows on the ground below. Our final destination is planet Q9J4, a world that has intrigued scientists and explorers alike for decades. This planet is a mystery wrapped in clouds, a celestial enigma that has kept its secrets well hidden. Q9J4 is completely covered in thick, swirling clouds, making it impossible to see what lies beneath from our vantage point in space. We can't see its surface from space, and this has only fueled our curiosity and imagination. Scientists believe that Q9J4 might have a warm, watery surface, potentially teeming with unknown forms of life. Some even think there could be life hidden beneath the clouds, life forms that have adapted to the unique conditions of this mysterious world. Imagine a planet with floating cities hidden from view. These cities could be home to advanced civilizations, living in harmony with the planet's environment. Exploring Q9J4 would be a challenge, requiring advanced technology and brave explorers willing to venture into the unknown. But it would also be an incredible adventure, a journey that could change our understanding of the universe and our place in it. What secrets lie beneath the clouds? Could there be ancient ruins, hidden treasures, or new forms of life waiting to be discovered? We can only imagine until we dare to explore. The mysteries of Q9J4 beckon us, inviting us to uncover its secrets and expand our horizons. These hidden planets are just a glimpse of the wonders that might exist.
Humanity's knowledge of the solar system has grown incrementally over the centuries. Up to the late Middle Ages, Renaissance, astronomers from Europe to India believed Earth to be stationary at the center of the universe and categorically different from the divine or ethereal objects that moved through the sky. Although the Greek philosopher Aristarchus of Samos had speculated on a heliocentric reordering of the cosmos, Nicolaus Copernicus was the first person known to have developed a mathematically predictive heliocentric system. Heliocentrism did not triumph immediately over geocentrism, but the work of Copernicus had its champions, notably Johannes Kepler. Using a heliocentric model that improved upon Copernicus by allowing orbits to be elliptical as well as circular and the precise observational data of Tycho Brahe, Kepler produced the Rudolphine tables, which enabled accurate computations of the positions of the then known planets. Pierre Gassendi used them to predict a transit of Mercury in 1631, and Jeremiah Horrocks did the same for a transit of Venus in 1639. This provided a strong vindication of heliocentrism and Kepler's elliptical orbits. In the 17th century, Galileo publicized the use of the telescope in astronomy. He and Simon Marius independently discovered that Jupiter had 4 satellites in orbit around it. Christian Huygens followed on from these observations by discovering Saturn's moon Titan and the shape of the rings of Saturn. In 1677, Edmund Halley observed a transit of Mercury across the Sun, leading him to realize that observations of the solar parallax of a planet, more ideally using the transit of Venus, could be used to trigonometrically determine the distances between Earth, Venus, and the Sun. Halley's friend Isaac Newton, in his magisterial Principia Mathematica of 1687, demonstrated that celestial bodies are not quintessentially different from earthly ones. The same laws of motion and of gravity apply on Earth and in the skies. The term solar system entered the English language by 1704, when John Locke used it to refer to the Sun, planets and comets. In 1705, Halley realized that repeated sightings of a comet were of the same object, returning regularly once every 75 to 76 years. This was the first evidence that anything other than the planets repeatedly orbited the Sun, though Seneca had theorized this about comets in the 1st century. Careful observations of the 1769 transit of Venus allowed astronomers to calculate the average Earth-Sun distance as 93,726,900 miles, or 150,838,800 kilometers, only 0.8% greater than the modern value. Uranus, having occasionally been observed since antiquity, was recognized to be a planet orbiting beyond Saturn by 1783. In 1838, Friedrich Bessel successfully measured a stellar parallax, an apparent shift in the position of a star created by Earth's motion around the Sun, providing the first direct experimental proof of heliocentrism. Neptune was identified as a planet some years later, in 1846, thanks to its gravitational pull causing a slight but detectable variation in the orbit of Uranus. In the 20th century, humans began their space exploration around the solar system. starting with placing telescopes in space. Since then, humans have landed on the Moon during the Apollo program. The Apollo 13 mission marked the furthest any human has been away from Earth at 400,171 kilometers. All 8 planets have been visited by space probes. This began with Pioneer 10's encounter with Jupiter and Pioneer 11's encounter with Saturn. The remaining gas giants were first visited by the Voyager spacecraft, one of which, Voyager 1, is the furthest object made by humankind and the first in interstellar space. In addition, probes have also returned samples from comets and asteroids, as well as flown through the Sun's corona and made flybys of Kuiper Belt objects. 6 of the planets, all but Uranus and Neptune, have or had a dedicated orbiter. In the grand theater of the cosmos, there are giants who command attention. And then, there are the small, forgotten actors. Welcome to the stage of the dwarf planets. Tiny, distant worlds that exist on the edge of our understanding, but whose stories are no less captivating. Pluto. Once the 9th planet, now the most famous of the dwarfs, out here, 3.7 billion miles from the Sun, days are long and the air is thin. It's a world frozen in time, sculpted by ice and methane. But don't let its size fool you. Pluto is as complex and dynamic as any world. Look closely, and you'll see Pluto's heart, a region called Tomball Regio, where glaciers flow like rivers and mountains rise like frozen skyscrapers. This tiny world, with its unexpected beauty, still holds secrets deep beneath its icy crust. Chiron the Wanderer, half comet, half dwarf planet. Found between Saturn and Uranus, this small, icy body blurs the line between planetary objects and comets. It's a cosmic misfit, a mysterious mix of rock and ice, shedding layers of gas and dust, leaving a faint trail like a forgotten traveler. Some call it a centaur, others a comet. But in the vastness of space, Chiron simply exists, caught between worlds, between definitions, between orbits, a reminder that not everything fits into neat categories. Far beyond Pluto lies Eris, the rebel. Named after the goddess of discord, Eris defies convention, nearly the same size as Pluto, but with a mass so dense that it shifts the balance of what we thought we knew. Out here in the cold and the dark, Eris circles the Sun in an orbit that takes 557 Earth years to complete. Imagine, a single year that spans centuries. For most of its journey, Eris hides in the shadows, revealing itself only briefly before retreating to the unknown. Haumea, the spinner. Named after the Hawaiian goddess of fertility, this dwarf planet dances through the Kuiper Belt, spinning so quickly that it's stretched into an elongated shape, a world that refuses to sit still. Haumea isn't just a strange shape, it also has 2 moons, Hyaka and Namaka, each caught in its rapid dance. And beneath its icy surface, who knows what treasures may lie hidden. A world in constant motion, a mystery in every turn. And here we find Make, the quiet observer of the Kuiper Belt. Named after the Rapa Nui god of fertility, it watches the cosmos with a red-tinted glow, its icy surface reflecting the faint light of the distant sun. It's a world without atmosphere, a place where silence reigns supreme. But even in this isolation, Make offers hints of its past, its red hue, a reminder of the organic compounds that once might have drifted across its surface. Chapter 9. Galactic Position. The solar system is located in the Milky Way, a barred spiral galaxy with a diameter of about 100,000 light-years, containing more than 100 billion stars. The Sun is part of the Orion Cygnus arm, orbiting close to the galactic plane. Its speed around the center of the Milky Way is about 220 kilometers per second, completing one revolution every 240 million years. The solar apex is near the constellation Hercules, towards the bright star Vega. The Sun follows a nearly circular orbit around the galactic center. where the supermassive black hole Sagittarius A** resides. The solar system's location in the Milky Way influences the evolutionary history of life on Earth. Earth's position in the local spur provides long periods of stability for life to evolve. However, the changing position of the solar system could explain periodic extinction events on Earth.
As we navigate the final frontiers of our solar system, we leave behind a trail of knowledge, inspiration, and hope. Our legacy is one of tireless exploration, fostering a spirit of wonder that will lead generations to come. We celebrate the wonders of our solar system and answer the call of the cosmos. Join us as we pave the way for new journeys into the unknown, and remember, this is not the end.